Here's an additional example of a one-way Anova. This time we're going to do it on our TI-84 calculator. We have a random sample of 18 students which is selected and divided evenly among 3 teaching methods. So we have an experimental design with random assignment. Therefore, we can assume independence. After a semester, all students take the same standardized final exam. So what we need to do is enter these values into our calculator first, where the traditional is going into list 1, flipped into list 2, and online into list 3. So we're going to go to Stat, Edit, clearing out our lists. Our traditional was in list 1, so the first value was 78, second value was 85, then 82, 76, 80, and 79. List 2 over here, we had 88 in the flipped, 90 was the second student, 92 was the third student, then we had 87, 85, and 89. And last one was our online class, which was 75, 70, 68, 72, 74, and 73. Then we go to Stat, Test. We're going to go down to Anova Test. There it is. Now we have to enter in our list. So we're going to enter list 1 by clicking second 1, then the comma button, second 2, which enters L2, comma, and then second 3, close parentheses, hit enter, and we have a full summary over here. Our F statistic is 53.98. Our p-value is 1.4 times 10 to the negative 7. So again, that's approximately 0 rounded to 4 decimals. Therefore, we're going to reject the null, and we would say there is sufficient evidence that at least one of these means is different. Now I'll do one more example on Statcrunch. So this is looking at a list of professor salaries from 2018 to 2019. I have research, other doctoral, masters, and we want to see if there's a difference. We also have a lot of different fields listed. It's a very large data set if we go down. So we have about 87 different groups. So let's run this Anova test. So the first thing we might want to do is look at the box plots. So I'm going to select all 3 of these, research, other doctoral, masters. I do like to draw these horizontally. I can, fill in my mean and median if I'd like. And over here is my graph, so I can see it definitely looks like there's some differences as far as the spread goes, with the research being most spread out, with the masters being least spread out. I do see that there's some outliers for each of the sets, so this kind of indicates that these may be right-skewed distributions. And then over here looking at our means, there also seem to be some differences. So let's check the normal quantile plots, which is something to check if the population comes from a normal distribution over here. So we're going to look at the QQ plot. We're going to, again, look at each one of these. And here is our first graph. Really what we're looking for is for these values to be very close to the straight line. This is actually looking at our data set and it's assigning different z-scores. So don't confuse that with like linear regression, but we do look for the straight line pattern. We don't want to have any curvature. And generally, when at the tail ends, our values go away from the line that indicates some skew. Here is our second, the doctoral, and the last one is the master's group. So all three seem to have some skew to it. So we can also confirm by looking at maybe a histogram of each of these graphs, just to kind of confirm what we believe. And again, this is our sample data, and we're trying to say something about the population. So based on our sample, which hopefully is representative of the population, it looks like each of these populations is right skewed. So that was one of the requirements. We can assume the independence, that each group, within the group, the professors are independent as well as between the groups. So there's not a real issue with the independence. Our variances need to be the same, which again, it looked like there may be some skew, and therefore the variances are not the same. So we're going to proceed over here with caution. We're going to run the Anova test, and one thing we can do within the Anova test is we can check for those equal variances. So in our example over here, I have my data in 3 separate columns. So I'm going to choose over here selected columns. If my values are all in a single column, so let's say I have the salaries all listed in a column, and then my factors like the type of professor would be listed separately, then I would go with the second option. So in order to test for the homogeneity of variance, I'm doing Levene's test over here. We've already looked at the QQ plot, so we're just going to run our Anova right here. This gives us a summary on the top. It tells us the number of values, the means, the standard deviation, the standard error. Certainly we can see between our samples there are some differences in mean as well as the standard deviation. Looking at our f-stat, we can see that it is 20.5832 with a p-value of less than 0.0001. Therefore, we're going to reject the null, which states that there is sufficient evidence that at least one of these means is different. Looking at the Levene's test for homogeneity of variance, over here, our null hypothesis is that each of these variances is equal to each other. So because that is one of the requirements for the analysis of variance, this is actually the one time we are looking for a large p-value in order to fail to reject the null. Now this p-value is very small, so again, as we saw from before from the box plot, we probably can't assume that the variances are equal. So there are a couple, challenges with our data set over here where our conditions weren't given. However, we would still run the test with some caution and look at those results.